If the production is increased, the price is reduced. If the demand is increased, the supply is decreased. If anybody want to do for correlation, of course, we need to select the buy model. Whatever you are studying the correlation, you need to think always the external factors, how it is influencing. If anything in future, if you want to predict our sales prediction, production prediction, or demand prediction, so the correlations will be very useful. Hello everyone, a warm welcome to one and all. I am Natesh, lecturer in Commerce, Vidhyaashram First Grade College, MYSURU, the Temple of Excellence. We are in the Unit 4, Session 1, 3rd semester BCom Business Statistics, Correlation and Regression. Okay, and today my agenda, you will get to know the meaning and definition in the correlation. What correlation? Correlation. Okay, there are two factors, how it is connected. And correlation and causation, what exactly, what and all the cause we are identifying, why it is important, and the uses or utility of correlation analysis. Most of the area they are using the correlation analysis. And the types of correlation, there are different types of correlations are discussing, okay, and the method of studying correlation. So here, today my agenda, so related to the correlation. And the first one, you need to know the general meaning of correlation. So when you are writing general meaning, so husband and wife are dependent and independent, height and weight. There are two X factorial. In the measure of central tendency and the measure of dispersion, we studied the X series, the set of values given X and Y. Okay, so here how it is related. And generally it can be seen that who are tall will have greater height. So because there are different factors will be identified based on the correlation, okay. So here height wise, weight wise, when we are trying to, for example, height is an X series and weight is an Y series. So, and those who are short will be a lesser weight. See, compared to short people, so the weight is more only. So in case of short people, the weight also less. So we are how it is related. And thus height is denoted in the X series, because any problem if you try to solve, the X series is very important. Now how one factor, one variable we identify height, and weight is one more variable, how it is related. So if you take the tall person and even the shorter person having how the difference weight we are finding. So the same thing we are just connecting, finding the relationship. For persons show they are correlated. On the other hand, production is one variable and price is one kind of variable, or supply is one variable and demand is a variable. Okay, so there are different types of variables we are identifying, how which is related. So Y price is denoted in symbolic Y. Vegetables show variance and opposite directions. So there are different types of variables we are identifying. Here, higher the production, the lower would be the price. Higher means you are trying to produce mass production, the price will be reducing. So if anybody is purchasing only limited quantity, in case of if they are trying to go for bulk quantity, the price will be reducing. No? So of course, we are finding a relations. In both the above examples, so there are too many examples to understand the correlation. So the variable X and Y show the related variations we are finding. Okay, if the production is increased, the price is reduced. If the demand is increased, the supply is decreased. So the different types of variables we are finding. So and so they are correlated. So based on the correlations only, because there are different area they are using a correlation. And there is a standard definitions, okay, according to L.R. Corner, if two or more quantity vary in the sympathy so that the movement in one tend to accompanied by the corresponding movement in the other, because only one variable we are not finding any relation. So we are trying to go for comparing two variables. Okay, if you take example height as weight or demand and supply, so there are two variables, two or more variables we are finding. So if any anybody want to do for correlation, of course, we need to select the bi-model. Okay, so unimodel, only one variable. So we are always depending for bi-model. Okay, so in case of the correlations. And according to Ya-Lun Chow, say that correlation analysis attempt to determine the degree of relationship between variable. For example, how x is depend on y or y is depend on x. So what is the relationship, the degree of relationship we are finding using a different variables. Okay, moving next. Correlation and causation, according to my agenda, today agenda, the meaning and definition, the correlation and causation. Causation means what cause, what are the cause and effect. For example, the heavy rain. So how we are trying to find out the cause. Okay, so at the time of production, generally speaking, correlation implies causal relationship. Correlation always we are trying to connect with the causal relationship. For example, when we say that there is a high degree of correlation between rainfall, high degree, and crop yield. So, for example, the rainfall, one variable x you can consider, crop yield you can consider y. Okay, how it is? So, we mean that when rainfall increase, of course, the crop also increase. Okay, because everybody, all the farmers are depending, okay, rain. So, vice versa. So, here the rainfall is a cause. You need to identify the cause. The rainfall is a cause, yield is a effect. Okay, so the vice versa. If the rainfall is a decrease, the crop also decrease. Okay, so another example. Whenever price change, the demand also change, because the price is considered an x or demand is considered y, because of price changes, the demand also. If the price is a decrease, the demand also increase. Does the price cause? Here identify price is a cause and the demand is an effect. Okay, of course, each and every correlations example, we are finding a cause and effect. But this general notions does not hold good way always. The presence of high degree of correlation, because how much change? If the price change, so how much it is changed? So how it is connected to the demand? So of course the degree we need to identify. Between variables do not necessarily mean that the existence of causation. Okay, we are trying to find out the cause and effect. So there are many possibilities with regard of cause and effect relationship, because if the height, weight, if you try to get an examples, too many examples, of course you are finding a effect as well as cause. Moving forward. So here there is two series of data is given. We are using one series of data, we are not finding a cause and effect or correlations. May show high degree of correlation, but this may be purely accidental or chances. Okay, accidental. So sometime we can predict, something we cannot predict. So in that case, for example, the number of car produced is increased. Of course, the number of accidents also increase because of increase in the production. Everybody is trying to show the interest or purchasing the car. Okay, so of course they want to travel with the help of road transportation. Okay, when it is too much crowded, okay, there is no completely the traffic system, the traffic management, how it is. Okay, so based on the traffic management, so then also in the highway there are too many accidental we are finding. Okay, so here even though they are not related, by chance both of increasing. Okay, because the correlations when is predicted, of course we need to study the X factor, X variable and Y variable, how it is related, and both the variables being influenced by the some external factor. So all the company cannot expect 100% sales for all the years. Okay, too many years. If they are surviving, of course there are competitors can arise. So the competitors also producing the same product. So there can be more chances. Okay, you can lose your market share. So sometimes instead of one variable influencing the other, both the variables are influenced by the external factor. So whatever you are studying the correlation, you need to think always the external factors, how it is influencing. Okay. So for example, yield of rice and yield of wheat per acre is increasing because too many crop which is related to wheat or rice or any vegetable because of something weather condition. Okay, of course you can expect the production what you exactly expecting, the crop you are expecting. It may be due to good rain or fertilizers used. Okay, so if you start going for the modern organic, so of course your production, your crop, okay, yield you can find out. Now uses and utility of correlation analysis, where exactly the correlations can be used. So the study of correlation immense use of practical life, because every businessman, even every field, they try to use the correlation analysis, which is very important analysis in the different field. So with the help of correlation analysis, we can identify the directions. Of course, the directions where, for example, price is a decrease, demand is decrease, the directions also we are finding, the movement we are finding, or nature of the relationship between variable, how the individual x variable and y variable are related. With the help of correlation analysis, we can measure the magnitude or degree of relationship existing between variable, because we can measure the magnitude and the degree of relationship. Okay, high degree, low degree, medium, okay, like this we can measure. So we can identify the independent and dependent variable, because if you take a previous example, the crop yield is completely dependent on rainfall. So the average relationship can be summed up in single value of change. So the set of data, X series or Y series, what we did in the measure of central tendency, now finally when you try to go for correlation, which is giving the sum of value, okay, so the called coefficient of correlation, the sum value what we are getting, which is nothing but coefficient of correlations. The concept of regression is based on correlation. The regression, which is nothing but which is going back to the origin. Okay, we are trying to go for studying previous data. Okay, which is completely regression is depending on the correlation, which is used for prediction or forecasting purpose. So if anything in future, if you want to predict our sales prediction, production prediction, demand prediction, so the correlations will be very useful. So the types of correlation, and today my agenda which is related to types of correlation also. So based on the different criteria, so the correlations may be classified into different types. So here the positive, when the price is increased, demand also increase, no doubt, which is going in the same direction. And negative correlation, price is decreasing, okay, and demand is also increasing, opposite directions. And linear or perfect, if perfect you are getting 0, okay, and non-linear imperfect correlation, simple and multiple partial correlation, spurious or nonsense correlation, spurious or nonsense correlation. Okay, moving one by one. The first one, positive and negative correlation. So whenever you try to understand the positive and negative correlation, you need to draw depend on the y-axis and x-axis. So the direction of variation, assume here price and here demand. Okay, so here the x-axis denoted price and y-axis denoted demand. Okay, So the direction of variation of variable x. For example, you can write price is denoted x and demand is denoted y, you can write. Okay. So and y, the variable x and y determine whether the correlation positive or negative. So when the value of the two variable move in the same direction, so either it is going for right side, the same direction. For example, the price 10 rupees increase, the demand also 10 rupees increase. Okay, the price is 10 rupees, the demand also same. Okay, if the price is increased 20, the demand also having a same demand. Okay, so which is going for the positive correlation, the same direction. That is increase in the x followed by increase in y. If the price increase, demand also increasing. Okay, so the same direction or vice versa. So increase in the x followed by the decrease in y. Okay, so then the correlation between x and y is a positive. So here increase in x is followed by increase in y, or decrease in x followed by decrease in y, the same direction. If it is a decrease or decrease, or increase or increase, so that is positive. On the other hand, when the value of the two variables move in the opposite direction, for example, the price is a decrease, okay, the price is a decrease, and demand is increase, so which is going for the negative direction. Okay, so price is increased, demand also decreasing, so which is going for the downward. Okay, which is going here positive, which is going upward, which is going for negative, downward. Why reverse? Inverse direction. An increase in x is followed by decrease in y. Okay, that means your production increase, your supplier decrease. Okay, so there are different types of variations. So here the decrease in x is followed by increase in y, opposite direction. So then the correlation between x and y is said to be a negative, because which is not going in the same direction. But in case of positive, both x and y is going for positive direction. That's what which is going for upward. Okay, and next linear and non-linear correlation. Linear means perfect. Linear and non-linear correlation, or linear, or you can say perfect correlations. If the amount of change in one variable tend to bear the constant ratio that the amount change in the other variable. So what exactly the linear and perfect, which is related to the ratio part. Okay, so if 5% increase, here also same 5% increase. So the correlation between them said to be a linear and perfect. Okay, if the price 10% and demand 10%. In a graphical sense, linear correlation form the straight line, which is always going for straight line like this. Okay, a perfect linear correlation may be positive or negative. It numerically coefficient may be always +1 or -1, which is a linear. Okay, so these are the limit of covariation. So in the perfect, non-linear or curvilinear or imperfect, if the amount of change in one variable does not bear the constant ratio the amount change in the other variable. Okay, if one variable, if it is changed, other variable cannot be changed. So the relationship between them is said to be non-linear. Perfect means x is change, we are finding change, and y also getting change, obviously. But here x is not changed, y can be changed. So that is curvilinear. In a graphical sense, it will not form a straight line. it will have a curvature. Curvature means what? Like this it is going. So which is looking like curvature. One increase, decrease, decrease to increase, then increase to decrease, like this the curvature. Non-linear correlation always have a numerical coefficient less than unity. Unity means always 1, which is less than or ranging between +1 to -1. So less than, which is going for lefts. Now, third type, simple multiple partial correlation. Simple, the name only suggesting. Simple correlation when only two variables are studied. Only two variables. The correlation is completely bivariable. Okay, that means at least two variables. So using only X series, we cannot comparing with the any other variable. So we need to select at least two variables. Okay, so that is a simple correlation. Okay. It's simple correlation. For example, the correlation between rainfall is denoted one X variable and yield is Y variable. So at least when you try to go for correlation, at least two variables you have to depend. Now, multiple correlation, the name only two is coming for the simple and more than two which is related to multiple. If more than two variables, okay, if you want to do correlation, at least the two variables are very important. So, in case of multiple, you are trying to go for depending on more than two variables. Studies simultaneously, the correlation is said to be a multiple correlation. Okay, in case here we are taking a 2, so X and Y, here we are taking more than two variables. Okay, for example, X, Y, Z also you can take. So, in this case, for example, the correlation between rainfall, if you are expecting a yield which is based on the rainfall as well as the quality of fertilizer you are using, okay, so the good seeds used, okay, so here rainfall is X, fertilizer you are using, you can consider Z, and of course you are expecting a yield which is nothing but Y, okay, multiple correlations. And partial correlation means you only 50%. When out of many variables in a function, the phenomena of covariations between two variables is studied at a time assuming other variable are constant. If you try to connect a number of variables, so one particular variable is a constant, it won't change. It is said to be partial correlation. Very simple. Spurious or nonsense correlation. That means there is no correlation. Okay, we are not comparing. So in that case, we can say it is a spurious or nonsense correlation. Okay, height we are comparing with the rain. It is possible, not possible. The height you need to compare with the weight or age group. That is a correct correlation. If you are trying to compare height with the rainfall, which is not at all correlated, okay? So, when there is a correlation between two variables, it may be that change in the one variable is caused the change in the other. So, because the relationship we need to find out, okay? There is a correlation based on this some logical relationship only. Okay, and causation. Sometimes even two variables are independent of each other. There is high degree of correlation between them. Of course, independent or always depending on the dependent variables. Or dependent variables, sometimes it is depending on the independent variables. So, if there is no relations, logically we cannot take the relations. So, which is coming under the nonsense correlations. Okay, such correlations between unrelated variable is called spurious or nonsense correlation. Here there is one best examples to understand. For example, the number of marriage is increase, okay, increase, and the number of death increasing. How it is connected? Which is not at all connected. Okay. So in case the number of marriage increase, the number of birth is increased, means which is a correlated. Now in case of death, it is not at all connected. So logically, there is no meaning such a variation or correlation. Moving forward. So here the method of studying a correlation, there are different types of methods we need to identify. So based on this two standard here, so there are, one is graphical method. Under graphical method, the scatter diagram is okay, and correlation graph. So under mathematical method, there are three types. One is Pearson coefficient of correlation, and Spearman rank correlation coefficient, and concurrent deviation method. Okay, and today my focus only on the graphical method. So what do you mean by the scattered diagram? Scattered means what? The data is spread. Is it clear? So the scattered diagram is also called dot diagram. Dot, because you are using a y-axis and x-axis using a dot. Okay, only dot we are finding. That's what we call it as a dot diagram. So it is a chart preparing a represent relationship between two variables. Because you know y-axis and x-axis. Whenever you try to use a graph, of course you need to select the scale for x-axis and y-axis. So y-axis represented one variable, x-axis represented one variable. So that's what, two variable. The rule of plotting the dot, the same as in the case of a line graph. What we are doing, for example, line graph, so here like this we are extending. But in case of dot matrix, dot diagram, we are trying to go for the using a dot. Okay. So variable x show on the horizontal line. The variable x is showing for the horizontal line. That means what? The horizontal which is going for like this. Okay. And scalar, which is nothing but the y-axis and x-axis. The x-axis which is going for the x series. So which is looking like a horizontal. The y-axis which is going for vertical. Okay. So both x and y is a two scale is selected. Two variables we are selecting on the vertical scale. And only one dot would be marked for each pair of the two value. Okay. Because at the time when you are plotting the data, in the coming slides you can get more clarity. So the way in which the dot lie on the scatter diagram, because you are using x-axis and y-axis, we are just marking the dot where it is intersected. Now x and y value where it is intersected, we are putting one dot. That's it. Show the type of correlation. If the dot show upward, which is going for upward, which is positive, we are finding. Okay. So what is the degree of positive and negative we are finding? That is also in the coming slides you can get more clarity. Downwards, the two variables are said to be correlated if the dot show the curvilinear path upward or downward, which is going for right direction or left direction. Okay. Or is less degree of correlations. We need to find out. If the dot do not show any clear path, which is somewhere like this, a scatter with a completely diagram. So x-axis and y-axis going together, the dot is marking. So then we are finding there is a relations. Or zigzag. There is no correlation between them. Figure 1 to 9, you can understand the story. There are too many scatter diagram using a value basis. The first, see the scatter diagram, the linear correlation. Linear correlation. In that we are finding linear means what? Perfect. So the x-axis, y-axis and x-axis which is going the same direction we are finding, the same ratio is going. So that's what we call it as a perfect positive correlation. The value is always 1. If you try to calculate or simplify your problem, if you are getting exactly 1, so there is nothing perfect positive correlation. If you going for second diagram, the strong strong positive correlation, because which is a perfect correlation. So which is going for example 0.5 to which is increasing till we are getting 0.8. So here y-axis and x-axis. When you're putting a dot, when you're marking a dot, so which is a strong relationship we are finding. So that's what we call it as a strong positive correlation. Now third diagram. Here the value we are getting exactly 0.5. Here highest strong. Here strong positive. Here very weak, because we are getting the value 0.5. So see, the dot is how it is spread. In case of here, so it is very close. But here the dot marking wherever you mark, which is going for the scattered completely, there is a lot of distance we are finding. That's what we are finding, which is a weak positive correlation. Next one. Spurious or nonsense correlation. There is no relation. The x and y, when you are marking the dot, which is completely scattered, spread. So there is no relation in between x and y. That's what. So which is nothing but your 0. There is no correlation. No correlation. So next one, weak negative correlation. That means which is going for negative, means minus sign. So we are getting minus 0.5 exactly. So which is going downward. So that's what we call it as a negative, weak negative correlation. Now if you go for strong negative correlation, so there is a, if the value is going, see with the dot is very close. So that's what which is going for the downward direction. The value we are getting minus 0.8. That's what which is a strong negative correlation. And here no correlations are same thing. And perfect negative correlation, perfect positive correlation we got plus, perfect negative correlation which is going downward. So from the y-axis to x-axis which is going for the downward. So value we are getting minus 1 we got, means which is going for the perfect negative correlation. And weak negative correlation means 0, minus 0.5 which is repeated. Keep on watch for next section. Thank you.